The epic testing continues. So this is a little bit more vlogish, I guess, but just wanted to give you a status update since people seem to be interested. My last video was on the 2990 and a little bit of epic and talking about core prio. Jeremy from Bitsum and I have been working on core prio and really scratching our heads because there's still work to do, but for Indigo, the results are very real, and a lot of people have reported in different interesting stuff in their workloads. And a lot of people have done testing, and there's been a lot of coverage and all this stuff, and it's very exciting. A lot of people have reached out to me from like inside companies, and so I believe that work is being done. There's definitely something interesting here. There's more to the story, but it's going to be exciting. But the thing that caught my eye was some testing that Phoronix did. And so it's very good testing. It seems to be pretty comprehensive. But there was one curious result. So they tested the NUMA disassociator with Indigo on a Threadripper 2990, and they tested without it. And there was one result that I have not been able to replicate. So for me, on Windows 10, on the Threadripper 2990, with Indigo in the bedroom scene, rendering the bedroom scene, I'm never able to score above like a 1.6, 1.7 ever without something helping the situation. But in the Phoronix test results, they were getting 3.68 and I think 3.70 with the NUMA disassociator, the Bitsum NUMA disassociator thing. And I don't think that's there's something suspect about that result. I have not been able to reproduce it. So I started testing Epic. I think adding results from the Epic 7551 would be the thing to do there. And to do that, I'm using my home-built Gigabyte workstation. Now Gigabyte has a fully ready-to-go workstation. You just drop in some memory and a CPU, and it's based around the MZ01-CE0 motherboard. That's an Epic motherboard. It's not a Threadripper motherboard per se. We've done our Threadripper testing also on a Gigabyte Aorus Extreme, and so we've got two workstations that are set up basically identically. I've been doing my testing, and the Epic 7551 is going to be a little slower for most things than the Threadripper 2990WX, owing to the much faster clock speed of the Threadripper 2990WX. But also even in Indigo, I'm not able to get any kind of a reasonable result. So I also decided to run Windows Server 19. And so the official results for this video or whatever are just going to be Windows Server 19 with the 7551 in die interleave mode, also known as Unified Memory Access Mode or UMA. And also in the default mode, which is NUMA, non-uniform memory access. In non-uniform memory access, the system has 4 NUMA nodes and 1 processor group, and that's a lot of fun. And just for giggles, we're going to talk about BCD edit and setting up a 4-socket config, but I'll get to that. I don't want to do that because it's also kind of like a frequently asked questions. So probably the number one question that came up in the last video talking about Threadripper performance is, how is Server 19? What about Windows Workstation and Server 19? Well, I've got some bad news for you. The Windows kernel, philosophically, Microsoft's attitude is one kernel. Now, mark my words, they're going to have to change that attitude. Somebody's going to have to be guinea pigs, and I don't think it's just going to be the fast ring people. My guess, again, armchair expert, there's probably people inside Microsoft laughing derisively, which is okay. Reach out to me. Let's be friends. I would like to learn from you. It's cool. I don't know everything. I would love to learn from people, love to learn from your experience vicariously as much as possible, because then I've got good data. I digress. Let me continue. So I think that Microsoft is going to ultimately experiment on people, probably running like the Windows Workstation version. Like they're probably going to tweak stuff. It's just one kernel. But when I say it's just one kernel, it's also a little misleading because there are a lot of options for tweaking stuff in the kernel. And so like with Windows 10 Desktop, there's one big GUI option that you have for tweaking the kernel behavior on Windows 10, and that's this radio button that says optimize for foreground stuff or optimize for background stuff. On Windows Server, that radio button by default is optimized for background stuff. On Windows 10, it's optimized for foreground stuff. And so theoretically, that little radio button would make like a web server run faster when it's in background services mode, or make an interactive application like Indigo run faster on like Windows 10. So we're doing our Windows Server 19 testing with the foreground thing bubbled in, also with our high performance profile. And I don't know what the Windows terminology is for the radio button is selected. So, well, the radio button is selected, bubbled in, whatever. We've got the high performance power profile. I am seeing the EPYC CPU clock up past its base clock of 2 gigahertz to like 2.5 gigahertz. And we're just running the Phoronix test suite from Windows, downloaded from the Phoronix website. So I ran in NUMA and UMA, and those results in and of themselves are interesting because a lot of results seem to improve in UMA mode, but there are some results that regress a little bit. But again, the regression with Indigo, the other point of the video was like this extreme sort of unsettling regression. And you also see that with some multimedia applications and some other applications that try to take thread management into their own hands and things go badly wrong. Programs like Handbrake, for example, I'm still looking into those. There is still stuff to be learned from those applications. But there is one other thing we can do with Windows Server 19 that we can't do with Windows 10, and that is a 4-socket configuration. So the other stone that was left unturned here, so like basically the one Windows kernel thing, the answer to your question is no, the kernel is basically the same for ARM and Windows 10 and Windows Server 19. And there's some options that you can tweak, the whole foreground background thing, but one would not expect to see a lot of differences in performance between a server version of the OS and the desktop version of the OS. There might be some minor performance improvements from the desktop version of Windows 10 to the Server 19 version, owing to the fact that Server 19 theoretically is newer software. But in terms of like performance differences that are always going to be there, I don't think so. And the reason I say that is based on messaging from the Windows internal kernel team. Hey, how's it going if you're watching this? And people that have written some of the blog posts on there talking about Windows internals and the kernel and just stuff that I've read over time. Like that would, if it does behave significantly differently, that's going to be surprising to me because that's not consistent with what Microsoft has said in the past. So there's that. Now the other thing that you can do is BCD edit. And so everybody always forgets about this, but with BCD edit, you can tell Windows to to use your available CPU cores and basically create fake sockets. This is useful for driver development. I think originally this was added for driver developers to be able to deal with situations where it might be a 2 or a 4 socket system. And so with Windows Server 19, it supports 4 sockets. Windows 10 for workstations supports 4 sockets. And Windows 10, the desktop version, only supports 2 sockets. And so with our single socket motherboard, like physically it's a single socket, we've got 4 Zen dies on that single carrier. So logically you think, well, if handling more than one NUMA node beyond the primary NUMA node that a thread is assigned to is the problem, perhaps we could split the processor in half into 2 sockets, which I did on Windows 10, but the performance was crap. It was like extra mega crap. And I didn't think that was interesting, so I left it out of the last video. But the thing that I could not do with the desktop version of Windows 10 was split it into 4 sockets, and that's really more analogous to the way that Threadripper is set up. So you can use BCD edit / set group size 16 to set the group size to 16, meaning that Windows is going to run 16 threads on a single socket. There's a fly in the ointment there, but we'll talk about that in a second. And so what that does is that will give you one socket that has 16 threads, and another socket that has 16 threads, and a third socket that has 16 threads, and a fourth socket that has 16 threads. And so with our 64 thread CPU, we've got 4 sockets. Like if you go into Windows and Task Manager, it'll be like there's 4 sockets, 32 cores, 64 threads, so 8. And that's just like our physical arrangement on the CPU. Even though it's only 1 socket and 1 CPU, it's 4 sockets. And all your applications, all the crazy licensing checks, if you've got some program that you run, and it's like, oh my gosh, this is a 4-socket server, it costs more. Yeah, all that stuff will work exactly the way that you think it does. And so, because you can always go up to more sockets, but you can't ever like lie and have it be less sockets because of the licensing. So running it in a 4-socket configuration, the performance was also crap, but slightly better. So again, check out the Phoronix test results. Yeah, so there you go. So the footnote, the fly in the ointment, the footnote for the most hardcore among you is just that when I'm using BCD edit to set the group size to 16, we're not necessarily guaranteed that all of the cores and threads are actually on one CCX, or well, not a CCX, but even on just one die, and that the mapping there actually matches. So I've noticed that in some motherboard updates, in some, maybe a Giza version, I don't know, but from Epic motherboard to Epic motherboard, from BIOS version to BIOS version, from vendor to vendor, the CPU numbering changes a little bit. And so when you look at, in Linux, when you look at which CPU number is on what NUMA node, it might be like 0 through 15 is on the first node, but that went away pretty quickly. And so now it's like 0 and 4 and, and it skips, it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those CPUs are on the first NUMA node. And then the second NUMA node is CPU 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And they're just kind of mixing it up. And there's some variation there, and I'm not really sure what that's about. So even though it's limited to 16, we're not necessarily guaranteed that those 16 cores and threads are physically proximal to each other, which may be a problem in terms of latency and some of the other variables that we're juggling here. So keep that in the back of your mind when you start to get results from this. Now with the CES announcements and chiplets and the I/O die, most of these problems are probably going to go away. They're ultimately software problems, but it's hilarious because I think AMD is going to have fixed these problems in hardware before the software people have had a chance to catch up, at least in Redmond. Linux, not a problem. Not a problem in Linux. But I did think the BCD edit result was interesting. And also thought it was interesting that I couldn't reproduce the really high score on Indigo on a 2970 or a 2990 with stock Windows 10 without using Core Prio. So I'm not sure if Core Prio was still running in the background or the service was still running in the background or what for that result at Phoronix. I'm not really sure, but something is not right there because nobody else has been able to get that kind of a score on Indigo without fiddling with the affinity on the Indigo process, at least specifically for Indigo. I can't say anything about any of the other applications because I don't know the applications well enough, but something is not right there, at least as far as Indigo goes. And this fix in Core Prio only fixes one class of problems. Are there other problems? Yes, absolutely. Are they all going to be fixable with some kind of a hack like this? No, probably not. But Indigo and programs in that family were some of the programs that were exhibiting the worst regressions. And so those were the most interesting to me. Currently, I'm working on Handbrake. Probably going to recommend RipBot instead of Handbrake because RipBot seems to be built to better handle the situation on that. Probably going to do a blog style video for that. And also looking into Premiere. Premiere is really super interesting. The guy that runs the Epos Vox channel, or Mr. Epos Vox himself, does a lot with Premiere. I know a little bit about After Effects and the engine in After Effects. It's a long story, but not as much about Premiere. And so I've been trying to get up to speed on Premiere internals and large complicated projects in Premiere to understand how Premiere goes wrong when scheduling things on both the CPU and the GPU. That is still a work in progress for me. I don't know if I'm going to have results in a few weeks or a few months. I'm going to work on it as I have time. So thanks to our patrons for that. You know, Patreon is what enables that kind of research. And if you want a workstation like I'm running with the Epic 7551, you should check out the Gigabyte pre-built, or you can build a workstation around this motherboard. So pretty awesome. I like the Epic 7551 is honestly mind-blowing for a workstation because I can use registered memory, so I can support higher memory capacities, and it's got, you know, the onboard interfaces, and I have 4x16 slots that are truly by 16, 128 PCIe lanes on Epic. So Epic has some advantages in the workstation category above even Threadripper, but there's no beating the Threadripper clock speed and just raw computational horsepower. But if you need 5 nines of stability, it's hard to go wrong with Epic. So that's a quick and rough status update. Also probably got some more workstation class stuff coming. This is a Tesla V100 with 32 gigabytes of memory. This is like a $10,000 graphics card. You can get it, well, you can get it for like 7 or 8. I did not pay that, but an anonymous benefactor for the channel has made it possible for me to purchase these at bargain basement prices. And so things are getting very exciting, being able to use Tesla V100s to do like AI testing and things like that. So stay tuned for that content. I wanted to just been a quick update. Let me know if you like this or didn't or whatever. Just wanted to answer some questions that I saw about the last video. I'm signing out, and you can find me in the Level 1 forums. If you have more questions, ask more questions in the Level 1 forums, and I'll try to address them or explain them or point out stuff that's happening. And for everybody that reached out, especially like working in the industry with the various companies and on the scheduler and whatever, thanks for reaching out. Don't hesitate to continue to reach out. See ya.